Hello, this is Ms. DB. In this video, we are going to work on multiplying polynomials. So we'll start by multiplying monomials, which only have one term, and we'll move on from there. There's several different methods that we can use to multiply the more complicated ones. But to multiply a monomial, you're really just figuring out using the rules of exponents. So for example, 2x squared times 5x to the third, you multiply the two numbers by each other, 2 times 5. And then for the x squared times x to the third, the rule is that if you multiply like bases, you add the exponents. So this would be 2 times 5 is 10, x to the fifth. So don't forget about your rules of exponents when you multiply polynomials. And there's a couple other examples that you can look at. So what you're going to do for these first 5 is exactly that. So if there is two coefficients in front of the variables, you need to multiply those together. So in number 3, you need to multiply 4 times 0.5. And then you need to multiply, I'm going to write this down, mn times nm squared. All right, so the 4 times 0.5, sorry, that's the same as 4 times a half. That's just 2. Now let's look at the m's and n's. So we have m to the 1. If there's no exponent on it, it's a 1. And we have m to the second. So the rule is if you have the same base, which is m, you add their exponents. 1 plus 2 is 3. For the n's, we have n to the 1, even though they don't show the 1, there really is 1 there, times n to the 1. So we would have n to the second power. If you can, when you're writing these, put the variables in alphabetical order. So m comes before n, so this would be the best way to write it. And you'll do the same thing for 4 and 5 and 1 and 2. All right, next we're going to look at multiplying a monomial with one term times a polynomial that has more than one term. So this is really the distributive property. So let's look at number 8. We have 9x to the third power times 3x squared minus 2x plus 7. We need to take the 9x to the third power that's in front, and we need to multiply it by every term inside the parentheses. So we have 9x to the third power times 3x squared. I'm going to put a minus because there's a minus here. And then it would be 9x to the third power times 2x. And then the next one's a plus. And that would be, again, 9x to the third power times 7. And then you just simplify each of these terms using the same rules we just did when we did a monomial times monomial. Really, we simplify using the rules of exponents. So 9 times 3 is 27. X to the third times x to the second. They're the same base, so you add their exponents, so x to the fifth. All right, next we have a 9 times 2. And then x to the third times x, remember that's the same as x to the 1. So that's x to the fourth when you add their exponents. And then on the last one, 9 times 7, that's 63. And there's only one variable term left, that's x to the third, so you just write that down. Then just go through, make sure there's no like terms. There's not, so this is the answer for number 8. All right, next we're going to get to a little bit more complex problems. We're going to multiply polynomials by polynomials. In this example, it's a binomial with 2 terms multiplied by a trinomial with 3 terms. Essentially, we're going to do the distributive property twice. That's if you want to multiply straight across in a row like this. You can also multiply these vertically, kind of like the old-fashioned multiplying in elementary school. And this one's handy. We've done this a little bit before with multiplying binomials by each other, is a table method. Now look through these 3 examples and think about which one works best for you. Don't forget that if you use the table method, you're not done once you fill in the table with all your products. You still have to write down all of them and then simplify. So the first 1, 2, 3, 4, in number 11 through 14 are all binomials times binomials, which means that we can use FOIL to multiply these. So we learned about this earlier this quarter when I think it was week 10. So you take the first times the first term, outer times the outer, inner times the inner, and last times the last. So I'm going to do that for number 11. First times the first term would be x times x. Outer term would be way on the outside times way on the outside. So x times 2. I'm going to write 2 times x though. And then the inner times the inner is the two closest to each other. So that would be minus 3 times x. And then finally you would do the last times the last, which would be negative 3 times 2. And then you simplify each of these. So x times x is x squared. 2 times x is 2x. Minus 3 times x is minus 3x. And minus 3 times 2 is minus 6. Now you can do some of this in your head if you're good at it. And then finally, I would add my like terms together, which are right here. You always have to check that when multiplying polynomials is if there's any like terms to combine. 2x minus 3x is minus 1x, and then the minus 6 would get written down. So you can use FOIL on 13, 14, or 12, 13, and 14 as well. But be careful, on 13 and 14, there are variables on the first times the first. So in 14, when you take the first term times the first term, you have a squared times 3a squared. So when you multiply this together, just like we did earlier, there's only one number, so that'd be 3. A squared times a squared is a to the 4th, because the rule is if you have the same variable, you add their exponents. And then you would go through and do the rest of it using FOIL. Now, when you have more than 2 terms in either one of your parentheses, you can't use FOIL. There's too many terms. These are much easier to keep track of, something like 15, 16, 17 if you use the table method. Otherwise, you have to do distributive property lots of times. Let me do a table method for 17. So I'd have a squared 2a. I'm going to put the first parentheses along the side, and then this one I'll put along the top, and this would be a squared minus 3a plus 4. And then I'll fill in the rest of my grid here. And so in each of these missing squares of the grid, I need to multiply. So a squared times a squared, we just talked about that, that's a to the 4th. And then I would take a squared times minus 3a, that's minus 3a to the 3rd, and then a squared times 4. So this isn't fast, but it's keeping track in a systematic way so that I don't forget anything. So a times a squared, that's the same as a to the 1. So that's 2a to the 3rd. And then I have these two I have to multiply. And that would be minus 6a squared. And I just keep going until I have all of my blank squares filled in. This last row will be a little bit easier because I don't have any variable for the minus 3. Negative 3 times negative 3 is 9, and then the a. Negative 3 times 4 is negative 12. Now you're not done. That's what I was saying earlier. You're not done with 17 until you write down all of what you got, what I wrote in purple. If you can do it in descending order, all the better. So I have a to the 4th. I'm just going to go across the top row. There's the top row. And then here's my next row. Now some of you are already saying, wait, you're missing some of the like terms. So I could have, before I did this, I probably should have, looked for the ones that were the same. So let's see, there's no more a to the 4ths, but this one and this one are both a to the 3rd. And look at, in this diagonal, these are all a squared, so this is going to make it a little bit less to write. And 9a plus 8a, those go together, and then there's only 1 minus 12. So instead of this, I'm going to make it a little bit easier, and I'll combine as I go. So again, there's only one a to the 4th. Now I will combine these in my head. 2a cubed minus 3a to the 3rd. Well, that's going to leave me with minus 1a to the 3rd. Okay, now I'll do the green diagonal. this one's a little trickier to do in your head because there's three numbers. So I have minus 3a squared minus 6a squared. That's minus 9a squared plus 4a squared. So I had minus 9a squared plus 4a squared. That would give me minus 5a squared. This one's easier. 9a plus 8a is 17a, and then my minus 12. Now I have checked. I don't have any like terms that haven't been combined, so that is the answer for 17. On 18 and 19, you can use FOIL for this part. Once you get what that is, you have to multiply each term by 3. And in 19, you can use FOIL, and then you'd have to multiply each term by 5x. So be careful that when you're done, you don't forget to multiply by this is the greatest common factor out in front of it that needs to be multiplied back. There is, you can multiply these horizontally or vertically as well, and you can do that by taking the distributive property as many times as you need to in the first parentheses. So in this 2a example, I would take x times 1, and then I do x times 3x, and then x times x squared, and then I do minus 2 times 1, minus 2 times 3x, and minus 2 times minus x squared. And if there was another term in this parentheses, then I'd have to do it one more time. So it's just doing the distributive property as many times as you need to based on how many terms are in the first parentheses. All right, next part we're going to look at is finding the area of figures that have variables in them. Remember that to find the area of a rectangle, you can do length times width, or you might know it as base times height, or maybe length times height. It's up to you what to call these. I used width and height in mine. So I use this as width and this as height. The main thing is you multiply the two sides together. So in this example, I have 12x, 12 times x for this one, and this one over here is also 12x. So that's kind of nice. Now to figure out the width of this red one, I know that it's 20 from here to here, but I have to subtract 2 x's from that because I don't have the whole thing. So the width of this is 20 minus 2x. It seems weird, but that's what it is. And the height of it is x. Okay, so we have 12x plus 12x for the blue part. And then for the orange part, we would have, here it is, 20 minus 2x times x. And then you just multiply it through. And the area is the sum of those parts, and then you can combine any like terms that you have. And in this case, there were several parts that could be added together, and that would be the area of this figure. Now your problem, number 20, is a little bit easier than that. We just need to figure out where to break this into two rectangles, like perhaps right here. That's not a very straight line, but you get the idea. There we go. And then find the area of this piece, which is just 8 times x, and then find the area of this piece, which is x times 3x, and then add those two parts together. Because they will not have the same exponent on the variable, you won't really be able to add them together. You'll just write it as an expression. Volume is found by multiplying, usually we say either length times width times height for a rectangular prism for a box like we have, or in geometry, if you remember, we often talked about this as being the area of the base. Big B means area of the base times the height. So we need to find the area of the base by multiplying, length times width. And then we need to multiply that answer by the height. And this is what they're doing in that example. And when you get done, you will just get an expression again. You're not going to get like a nice number here. So you're going to do that for 21 and 22. They both are very similar to the example. I'll start you out on 21. We are going to find the area of the base times the height. The area of the base is 3x plus 4 times 2x. And then we will multiply that by the height of x plus 1. There's no reason that you have to multiply this before you multiply the other one. You can multiply them in a different order if you decide to. I'm just going to go ahead and do it this way. This is the same as the distributive property. We have a monomial here times a binomial. So I need to take 2x, I'm going to go backwards this time, times each term in the parentheses. So I have 2x times 3x plus 2x times 4. And when I get that answer, don't forget that I'll have to multiply it by x plus 1. And now I simplify. So I'd have 2 times 3 is 6, x squared, plus 2 times 4 is 8x. Now I'm ready to go ahead and multiply that by the height. And you can use FOIL for this. So you would take the first times the first, 6x squared times x, plus the outer, 6x squared times 1, plus the inner, 8x times x, plus the last times the last, 8x times 1. And then you simplify each part, and then you see if there's any like terms. There will be. And that will be your answer. Do the same thing on 22, and then you'll be all done with this worksheet. Thank you very much and have a wonderful day.